right, first question. What is trigonometry? It is the study of triangle measurements. The study of triangle measurements. All right, so we have different ratios for trigonometry. We have sine, cosine, and tangent. Each acute angle of a right triangle has the following trigonometric ratios. So the ratio for sine, the ratio of the leg opposite the angle of the hypotenuse. So if we were standing here at angle A, it would be the opposite sine. This is always the hypotenuse. This would be your adjacent if we're standing at A. So it would be the opposite. If we're standing at A, the opposite over hypotenuse. So it would be A over C. But now if we're standing at B, the opposite side here is going to be B, so everything's going to switch. So I'm switching colors. So now this would be opposite, this would be adjacent, and again this still stays the hypotenuse. So the sine of B is going to be B over C. So we can use the same letters for each one. So cosine of A is going to be adjacent over hypotenuse. So if we look at cosine of A, again standing here, that'd be B over C. And then cosine of B, if we're standing at angle B, would be A over C. And then if we look at tangent, the ratio of the leg opposite the angle to the leg adjacent to the angle. So it's opposite over adjacent. So it would be A over B. And if you're standing at angle B, it would be B over A. Okay. There we have learned acronyms. SOHCAHTOA. SOHCAHTOA. And what that is it's sine, so the S comes from sine, of opposite over hypotenuse. Cosine is going to be adjacent over hypotenuse. And tangent is going to be opposite over adjacent. So this works for any of them. So I'm going to do that again. SOHCAHTOA. Okay, so sine is going to be opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So it's set up that way each time. So let's look at some examples here. Okay, so I'll go ahead and fill this in again. You should already have it filled in. If you don't really remember what the O, the A, and the H stand for, you can fill it in as opposite over hypotenuse, and you can abbreviate it. You could do adjacent over hypotenuse. And then tangent, you can do opposite over adjacent, if that helps. I just usually use the shorthand. So if we are standing at A, again, this is my opposite, then my hypotenuse doesn't change, and then this would be my adjacent. So I'll do each of those. Sine of A, opposite over hypotenuse, would be 5 over 13. And then cosine of A would be 12 over 13. Tangent of A would be 5 over 12. Okay. Then if I stand at B, things change just a little bit. Now this becomes my opposite, this becomes my adjacent. Again, this is still my hypotenuse. The hypotenuse doesn't change. So sine is opposite over hypotenuse, so it becomes 12 over 13. Cosine of C is going to be 5 over 13. And then tan of C is going to be 12 over 5. Okay, so go ahead and pause, and I want you to try number 2 and number 3. For number 2 and 3, though, you may find out quickly that you don't have the hypotenuse for number 2, and you're missing a leg on number 3. So we do have a right triangle. We can find that because we can use a squared plus b squared equals c squared. So I could do 9 squared plus 12 squared equals c squared, and I'm going to solve for that. So c squared is equal to, it's 225. C then is going to be equal to 15. Okay, go ahead and set up your proportions here. So opposite over hypotenuse. Go ahead and pause and try that. Okay, so there it is. You can pause and check this. The other thing is, though, that they do simplify, so you really should simplify them. So here, 12 divided by 15, so they're both divisible by 3, so it ends up 4/5. And you can simplify each of these. 9 and 15 ends up 3/5. And then this would end up 4/3, so on and so forth. So go ahead and simplify and then check. Alright, so there you have it. Those are the simplified versions of each of those. Now we're going to move on. Now that we can set up the problems, we're going to start solving. So we're going to start finding side lengths. Again, we're going to use SOHCAHTOA. Opposite, adjacent, that's what the A is for, hypotenuse, opposite over hypotenuse. Okay, so here we go. So let me keep going here. Here we go. Now we're going to find side lengths here. Make sure that your calculator is in degree mode when you're working with these. So let's go ahead and set them up. So finding side lengths using trig. We're going to, again, use SOHCAHTOA when needed. And I'm going to set it up according to the angle that I'm at. So for here, since I'm standing at this angle, opposite is going to be here. The adjacent side, opposite and adjacent are always the legs. And then I have the hypotenuse out here. Well, since I'm standing here and I have, since I'm looking for this piece and I have this piece, it's going to be the SO part, the sine. Okay, so sine is equal to opposite over hypotenuse. That's what I'm going to use. But I'm also going to put in my degrees. So it's going to end up being sine of 28 degrees is equal to x over 19. And here I can cross multiply, so it's not going away. Cross multiply, this ends up over 1. So I end up with x is equal to sine of 28 degrees times 19. So I'm going to multiply those out in my calculator. You'll hit, you can do sine 28, close off the parentheses, times 19. Make sure you close off those parentheses. So x is going to equal 8.9. We're rounding to the nearest tenth. Okay. So let's look at the next one. So on the next problem here, right here. Now I'm going to go ahead and, this is opposite because they're angles. Here's adjacent, hypotenuse. So again, I'm looking to see what I'm looking for, which is opposite, and what I have, which is adjacent. So that gives me the TOA part. Okay, so that's tan is equal to opposite over adjacent. So I'm going to go tan of 41 degrees is equal to x over 32. Again, cross multiply. So here I get x, and then I'm going to do tan of 41 degrees times 32. And if you're putting this in your calculator, you put tan first. Make sure that you put it in parentheses. So x is equal to 27.8. And nearest 10. Alright, last, so another one. So here, I'm standing here. Again, opposite, adjacent, hypotenuse. So if I looking for that, I have that. So it's adjacent over hypotenuse, which is the part. So cosine is equal to adjacent over hypotenuse. So cosine of your measure, 21 degrees, is equal to x over 26. And this is over 1. Cross multiply. X is equal to 26, I'm going to reverse the order here, times cosine of 21. If you're having trouble with your calculator, writing it in this order may help you out. So x equals, let's make sure that it's in degree mode, 24.3. Alright, so go ahead and pause it. I want you to try number 7. Alright, there you have it, 11.5. Alright, number 8. We're going to do the same idea. So set it up. I have opposite, hypotenuse. So that's sine is equal to opposite over hypotenuse. That's the so part in SOHCAHTOA. Then it's going to end up being sine of 33 is equal to 15 over x. And this is over 1. So when I cross multiply here, it's going to turn out a little different. I'm going to end up with x times sine of 33 is equal to 15. So now I have to solve this all the way through. So I want to know what x is. So I'm going to divide both sides by the sine of 33. So these cancel. X is going to be equal to, you take 15 divided by sine of 33 in your calculator, you get 27.5. Alright, go ahead and try 9, 10, and 11. Alright, there's number 9, 49.2. That was cosine. Okay, try 10 and 11. Alright, so number 10, x equals 8.1. Number 11, x equals 4.8. So now let's take a look at the next couple of problems here. So 12 and 13 are word problems, but they're not so wordy. We've talked about this before. So Jake leaned a 12-foot ladder against a house. So we have seen problems like this with the ladder. So here's your ladder. And it was a 12-foot ladder. Okay. The angle formed by the ladder and the grounds. So the ladder and the grounds here would be at the bottom. So that's our 68 degrees. Okay. How far from the base of the house did he place the ladder? How far from the base of the house did he place the ladder? So they want to know this guy down here. So again, as usual, since you're standing there, we have opposite, adjacent, hypotenuse. So since we have the ta part of the SOHCAHTOA, so it's going to be tan of 68 degrees. Sorry. Not the ta. Goodness sakes, it's the ka part. SOHCAHTOA. So, cosine of 68 degrees is equal to adjacent over hypotenuse, which is x over 12, and you're going to solve that as we have been. So cross multiply x equals cosine of 68 times 12. Make sure this ends up in parentheses in your calculator. So x equals 4.5 feet. Alright, so a ramp is used to load suitcases onto an airplane. So if you think about it, I have this ramp, and I have where they're loading it to at the top. Okay, that makes a right angle. It's my ramp. The cargo door is 7 feet from the ground. So if the cargo door is 7 feet from the ground, so it's 7 feet up, and the angle formed by the end of the ramp and the ground is 25 degrees, how long is the ramp? So I just read through the problem and placed things into my triangle. So if I'm standing here, I have opposite and hypotenuse, which is going to be sine. So sine of 25 degrees is going to be equal to 7 over x. So then I'm going to cross multiply. So I'm going to get x times sine of 25 is equal to 7. Divide both sides by sine of 25. So x is going to equal 16.6 feet would be my ramp. Okay, that is all for this lesson on trig ratios and sides.